Hi, I'm Baron Schwartz, and this may be a funny slide to some of you already. We do services from MySQL, and there's lots of people who want to keep MySQL up and make MySQL high availability, but before you understand how to keep it up, you need to figure out why it goes down. So I decided to start looking at that. Most people don't understand what they need to do for proactivity because they have no idea what is actually going wrong on their systems. And there's lots of sort of rules of thumbs and legends that go around. And a lot of these turn out not to be true. Some of them are true. But I decided not to guess because we have actually a rather large database of customer problems from many, over 1,000 customers who've come to us with downtime issues and asked us to solve them. So I decided to just do the scientific thing and look through that. Here's the quick version of the results of where the downtime issues actually show up. Most of the time it's not in the database, or let me rephrase that. The most common cause is not in the database, but it's actually in the systems that support the database. And then inside the database we get performance issues and replication issues. Replication is breakable in MySQL. And then we get data loss and corruption, and there's a few other things that are lumped in there, but it's kind of lost in noise. So in the operating environment itself, most of the issues turn out to be storage problems. There's other things like badly configured init scripts and bad management scripts and all kinds of little things that happen there, but it turns out that the biggest category was storage failure. So drilling into that, the most common thing that happens, of course, is somebody runs out of disk. SAN failures are another leading cause, not because SANs fail a lot, because people trust them not to fail, and when they fail, they're often very difficult to diagnose and fix because they're a big, complicated piece of machinery. In the performance problem slice of that pie, it's true that performance problems come a lot from bad SQL, but they also come a lot from bad indexing and from long-running transactions, what Postgres people would call idle in transaction. In replication, most of the time, the data on the master and the replica don't match. That causes replication to fail. And most of the time, this is caused by bad humans. In the data loss and corruption, again, it's humans, right? It's usually something like a dropped table. I'll get you into a little bit more details about this later, but the data loss itself is not the root cause. The human is not the root cause. It is usually not InnoDB, so if you are running InnoDB, you're about as safe as you can be in any modern ACID-compliant database, because InnoDB is very, very careful with its data. The root cause analysis. I said that the human is not the root cause. The problem is there is no single root cause. There's always a chain of failures. And if you stopped any of those failures, you would have broken the whole chain. So for example, the data loss. Let's say somebody goes and runs drop table on the wrong server. That would not have been data loss unless the backups were also broken, right? So there's always a chain of things that causes these problems to actually become downtime. In terms of prevention, now that I've breezed you right through what turns out to be about, I don't know, 25 or 30 pages of a couple of white papers that I wrote, I'm really giving you the very high-level view of this. Most of the time, it is bad change management. It's either changing things carelessly or not changing things. In either case, carefully managed change turns out to be very important to keeping a system online. And of course, in the operating environment, any database server, not just MySQL, but any database server is going to be relying on the four main resources that it requires to run. That's CPU, disk, network, and memory. And all of the external services that are layered on top of those things, like DNS. Where's our DNS guy here? Even DNS from the top providers will fail eventually, and unfortunately, MySQL has a DNS Achilles heel. There's lots of other things that can go wrong. But anytime those things that MySQL relies on goes wrong, you tend to get problems. So what can you do about this? My definition of high availability, this is something that people will often lump together with performance and scalability and fault tolerance and all sorts of other kinds of things. My definition of high availability is that the service needs to be not only responding, but responding with good performance. And the way that you do that is that you reduce downtime, and you increase the time between failures, right? So how can you actually do those things? Monitoring and graphing are a couple of the things that you can do. You want to monitor selectively so that you don't get a whole bunch of noise that people end up ignoring eventually. but you want to record all of the metrics that you can and keep them as long as you can. Those are actually the opposite of the way that I see people do that often. They will monitor and alert on way too much stuff and record way too little historical metrics. Proactivity. I identified a number of things that can actually be said to be proactive, and one of them is rebooting your servers, because it turns out that if you reboot a server that hasn't been rebooted in forever, guess what? All sorts of changes have been made to that system in the meantime, and you have no idea whether it's actually going to reboot safely. You'd better figure that out before it crashes and you have to reboot it, because that's the only way to get it back online. You can come to my talk on Friday to learn a lot more about measuring statistical variations in workload and understanding when problems are beginning to show their heads. You can drill down into systems at a very fine granularity from TCP traffic, which is what I'll be talking about. Using good quality tools that actually have unit tests is key. I spend a lot of my time writing tools. I've been doing this for years. And we've now got Percona Toolkit, which has started its life as MottKit, which is basically the toolkit for MySQL users. And it has many thousands of unit tests that protect you from bad things happening. Don't let sensitive, touchy things happen automatically. Make humans make those decisions. And if you want to, look at the 2 white papers that I wrote on this point called Causes of Downtime in MySQL and How to Prevent Downtime in MySQL, which are on our website. You also need to actually take action on this and assign this to someone to make sure that it happens. The takeaways I would say here is that untested scripts are dangerous. This is really back to that operating environment problem. This is where I see a lot of problems coming from. Tuning the server doesn't buy you much. People spend far too much time, quote unquote, tuning the servers. And it's not humans who are the risk, it's unprotected humans who are the biggest risk. Humans are actually your asset for getting systems back online as quickly as possible. That's all I got.
Thanks, Baron. Next up, we have Chris Burrows.
Got it. So hello, everyone. I'm Chris. Contact information. So I'm going to be talking about sort of a problem in design space and then one possible solution to it. So the problem is, in general, if we have a bunch of web servers, perhaps we have a website, so to speak, or some other like internet-facing sort of applications that are generating a lot of data. How do we get data from those like edge servers to somewhere where we can do something useful with it in a timely manner? So examples of the kind of data, access logs are sort of where we might start. The first step, various server metrics from CPU load to something meaningful to your application, like some percentile SLA you've set. Maybe have more application-specific, like activity data log about every interaction between a user and your website, so you can look later and say, did we do a good job? And what we want is for all of our applications, for us to be able to analyze the data that all of our applications are creating, and both about like the users interacting with it and like their metadata. And when do we want it? That was supposed to be like a rallying cry. But we really want it at our own pace. We don't really necessarily want it now, because we might have some fancy distributed Hadoop-like giant analytics system that wants to load things in every half hour, perhaps, or some other time pace where we're doing some sort of like metrically monitoring thing. We probably want access to the data right away. So the key idea here is that different consumers want all this data at their own different rate. So there's sort of a lot of like prior art in this sort of area of how do I move files around. So there's rsync and cron, which work great. I use that a lot. But once your files get too small or you have too many servers, it tends to work not so great. There's log aggregators sort of designed for this, like Flume and Scribe. They tend to be very focused on HDFS, that one like Hadoop case. And they tend to have a push-push model, which again doesn't let consumers consume at their own pace because someone is pushing them. And then there's sort of traditional message queues like ActiveMQ, RabbitMQ, which remember we started, like our first use case was access logs. And these queues tend to treat disk as a corner case as opposed to the common case. They tend to be slower with an asterisk because they're trying to do more complicated things like exactly one message semantics, which would be really cool. and they tend to maintain complicated consumption state in the broker. So if you want like an end-to-end argument there, go for it. So Apache Kafka is a program that developed at LinkedIn, basically for their set of problems along these lines. That was recently open sourced. It's currently in the Apache incubator. And the idea is it fits here in the middle between those traditional rabbit-style message queues that producers tend to send messages and expect an acknowledgement that something was done with them in a few milliseconds, and like log aggregators that might deal with like a batch of, I don't know, 5 minutes or whatever. Cool. So sort of the key design idea is that the messages are always persistent. They're always written to disk. There's not like a special like index queue that's only used sometimes if things spill over. You can consume from an arbitrary point in the queue, so you can rewind it, so to speak. If you're a consumer and you have some checkpointing mechanism and you crash, you can back up because you're in charge of where you are. And there's explicit support for coordination among producers and consumers using Apache Zookeeper. So if one of your brokers disappears, you can route around that, and you haven't like lost the ability for your system to function. So the idea is that it would fit here in the middle, where you have all of your various front-end servers generating data. You analyze it maybe by Hadoop, maybe some other data warehouse thing, maybe some sort of streaming monitoring service that's going to make lots of pretty graphs for you right away. And then they can all feed data back in, and you can analyze it again, so you know how you're doing. Have hopefully a virtuous cycle. Cool. So like design decisions made here. Messages or bytes. It's not tied to any particular serialization framework like protocol buffers, but it means you can't do anything fancy with the message. Queues are addressed only by byte offsets. There's no like time index. So your message format is offset and payload, and then your next message is that offset plus the length of the payload. So it's all like simple byte math. There's no caching layer other than the OS's page cache. We said that already. There's a very long design document if you would like to know more. And so on disk, the files are just flat files. If you can look up at these, and if your messages were plain text, you could see whatever it is you would send in with the little like binary byte offsets in between. Cool. So there's like design decisions that make things sound like, wow, this is great for this use case. That means there also ends up inevitably things it's bad at. So being page cache dependent means it does poorly if co-located with programs that are disrespectful of the page cache, because they tend to write in or read in lots of data and they never do anything with that again. Unfortunately, that tends to include really awesome useful tools like rsync. So if you have a use case where your producer would really like to know a message is consumed as received an ACK, like maybe you're pushing critical updates to your router tables or something because you have an awesome feedback loop there, probably not a great case for this. And if for whatever like architectural reasons you want consumers to be dumb, they don't have that option here. So this is performance of active MQ doing not what it's supposed to be doing. This is where there's a queue that's building up, it's on disk, and it's not being consumed. So we can see performance kind of degrades as we continue to push messages in and don't consume it. Kafka looks more like this, where since we're just appending to flat files, you can do that all day until you run out of the space. And usually there's an asynchronous mechanism for cleaning up files, like maybe you keep your access logs, so to speak, for 7 days. And the code's there, please fork it. If you happen to use it, let me know how it goes. Otherwise, feel free to find me for questions. Mr. Bell, man.
Thanks, Ben. Appreciate it. All right. Next up, we have Mr. Kurt Michael, otherwise known as Asenchi on Twitter. So Kurt's actually one of the most patient gentlemen I know. He has to work with me at Heroku, so it kind of has to be. Well, yeah. All right. There you go. Thanks, man.
It's been some cool talks tonight. So I'm going to talk about Yubuko, which is the new shared database implementation we're going to be rolling out at Heroku. So let's start. So I'm Kurt Michael. I'm a Hirokai. I'm on the Ops Clan, and you can find me essentially just about every service on the internet. So for those who don't know what Heroku is, it's a platform as a service founded in 2007. We originally started supporting Ruby. We released Cedar Stack and now support Logo, Node.js, Clojure, Java, and today we announced Python support. So I'm very excited about that. So early on, we had shared database for every app. And then with the Cedar Stack, you didn't get one unless, depending on the framework you used. So this is how many apps we were at last week. It's Tuesday, and this was Monday. So we have a lot of databases, as you might imagine. Around 180,000 Postgres databases, and that's multi-tenant, so it's not instances, but on more than one server. So our current implementation is called Shen, and it was written, gosh, I don't know when it was written, but a while ago, really early on, using AMQP to grab databases and do different control methods and stuff. And it's Postgres 8.3. It's missing quite a few features that we want. And it's getting old. It's starting to show its age. It runs on about 126 production servers now. And we also, the big thing we didn't like was that it's really integrated into the platform. So it's not its own service per se. It's really, what's the word? Baked in, I guess. There you go. So Jason and I started working on this in July, and we created Yobuko, which is a REST interface. It's a Sinatra web app that sits on every database server, and we've written a bunch of endpoints to do things like database creation, role creation, we're going to be able to, it's not quite there yet, roll different roles on databases so you can change passwords really easily without interruption systems, stats. We're going to put on Postgres 9.1, but maybe 9.2 after Robert Haas's slides. And we also released recently, Heroku did a Heroku Postgres, basically Postgres as a service. So we're trying to reach some type of feature parity with that as well. So it's a real easy migration plan going from a shared database system to a Heroku Postgres database. It's in alpha currently. And the cool thing about this, where before it was baked in, is we've implemented this as an add-on, just like any other service that you can do with Heroku. So it just runs right on Heroku. It's another app, and then it manages a fleet of databases, which is really cool, really simple, service-oriented architecture, real fun to do. And we've got more of a focus on security with this as well. So we are really kind of throwaway with our data, not with the data in the databases, but the data that manages the database. So database names are all random, passwords are all random, but we don't store those passwords anywhere. We just really easily can regenerate them without service interruption and stuff. So here's what some of the features will look like from the command line. Some of these kind of exist now. We don't like the underscore, so we'll figure out what to do with that at some point. Probably the cool one here is the migrate. We've got some plans for this, but when we go to do this migration, we want to give the option to the customer to do this. So this isn't something we want to just do overnight and flip the switch. We want the customer to be able to migrate their database. We want people to move off Shen to Yobuku, but we want them to be able to do it at their own time scale. So that's going to be pretty interesting to implement, and I'm looking forward to it. We've got a lot of the ideas, but not a lot of the code yet. So yeah, migrating 180,000 databases is going to be quite the task, but fun. So that's just a look at the new system. Cool. So, and we are hiring if you want to work on really cool shit with any language you want to use. Clojure, we've got some, I don't know if we have Java really running. We got everything running. And lots of jobs available. So come and work for us because we do a lot of fun stuff. Anyways, find me there. Thank you.
Now, I want to be clear. What he meant by losing data was that we run on Amazon. All right. I actually still have to download your slides, so if you could grab that.
Oh, yeah, I can improvise. Who needs slides? That's Artur. He just wants you to fucking buy an SSD. How many people bought an SSD after Artur's talk? Did anybody go on Amazon.com? You bought 3 of them? That's because you work for Heroku and you got the big dollars. That's why that happened. The rest of us were poor. It's not true. My company's fairly well funded, but it's all pension fund dollars. So whenever I buy an SSD, I'm like, woohoo, old person's retirement. Anybody else here on retirement money? I'm here on retirement dollars. You venture funded? Some of you are venture funded. Come on, raise your hand. Yeah, you've got venture money. So do you. That's right. That's retirement dollars right there, yo. All right, I'm going to talk about config management theory. I'm sorry. I was like, it's Surge. They're going to be super technical. Everybody's like, write a fun talk. I wrote a boring one. So you're my guinea pigs, but my talk is shorter than Infinite Jest. So, see, one guy read it. Okay, it was a big book. There's going to be a test at the end of this, and I'm going to ask what convergence, idempotency, and promise theory is. I love configuration management in a way that I think is rare. There's a couple of people who are probably about as dorky about it as I am. And I get irritated because every time I talk, I'm like, this is what convergence is. And the people are like, okay. And they don't care. So you guys are my guinea pigs. I'm going to teach you what convergence, idempotency, and promise theory are. And then I'm going to have you say it back to me at the end of this talk. And if you don't get it, it's not my fault. It's yours. So my example, I'm going to explain this stuff by installing Track. How many people have installed Track before? In the years before GitHub, it just means you've been here more than like 2 years. So this is the documentation. This is the table of contents for installing Track. And it's got 7 steps. Some of those have 3 stub steps. It's not actually all that easy. But it does illustrate the first point, which is you can't manage what you don't understand. If you can't write a document about how to manage the thing you want to automate or put it in configuration management, you're fucked. Got it? So if you can't write it down, you can't tell me how to do it, don't start trying to automate it because you're probably too stupid to do it. And then, once you understand how to do it, this is a Theo rule. Theo knows how to do it. He can tell you how, but you got to write it down so other people can work it out too. So I followed your instructions on the airplane, actually. This is why my talk didn't happen until like 10 minutes before I got up here. Is because I spent 45 minutes on the airplane installing Python, build tools, pip, virtual end, Postgres, because I'm coming to Surge, and there's a bunch of Postgres people here, and if I don't use Postgres, then I'm not cool. And a whole mess of other like Python deps. Also Subversion, and I decided that I didn't care about like Apache and ModWizgy and all the rest of it, right? So I just used Track straight up. It took me like 45 minutes. So it was mostly typos and me figuring out, like, I don't want to use the OS parts of Python and some other stuff. You could do it more or less fast, but this isn't really an outlier, right? I've been doing it 15 years. I've installed a lot of software. I wrote Chef, right? Like, I'm not new at installing random crap. It just sucked a little. So it's not an outlier. It's about how long it takes. So cool, I can do it by hand. So I had a little party for myself. I was like, woohoo, I ran Track. But then I wanted to do it again. So I wrote a script. This is what scripts look like. How many people wrote a script? Can't really read my script, but trust me, it's a fucking script. And what's good about this script that I wrote was that it totally worked, right? I rolled my VM back, I ran it. Goddamn if Track didn't install and run, right? And it had a really high degree of whip-it-uppitude, right? I just busted that script out. I didn't think about it. I didn't do work, right? I took the stuff that I wrote on the CLI, I slapped that bad boy in a text file, I put, pound, bang, bin, bash on it. Fuck it. I was running fucking Track, right? So here's what sucked. I'm not checking any error codes in this script. Not one. So if anything goes wrong, my script just keeps going. It's like, whatever, man, we're going to do it. So I could have solved that problem with bash -e, okay? I didn't. You should. So what's bad about my script, it's got some stuff in it that calls apt-get, right? And it calls pip. And so both of those things, depending on how you configure it, most of the time, they need a network connection, right? If something goes wrong with the upstream, those packages aren't there anymore, if I didn't run apt-get update, if pip is broken, if the Track website is down, they can't get the Python egg, everything breaks. That sucks a little bit. It's no big deal with apt. It turns out if you run, apt-get install 15 times, it'll just do it eventually, which is cool. Pip, a little less so. And the Postgres stuff, it's going to create a user in Postgres. It's going to build the database. I'm not using Heroku. So, I have to do all that stuff myself. And it breaks, right? Especially if it turns out that on the upstream, remember, I wasn't checking error codes, so it's just going to keep going. So if apt failed, then I'm going to try to create these Postgres databases. That's going to fail too, because, right, Postgres didn't get installed, so that sucks. Seems obvious, but how many people have done that before in their life? Totally did. So Nobody. I'm alone. I'm the only sucky sysadmin in the entire room. So this is why I'm here on pension fund money and you're not. So the other thing is, track itself, when you run the init-env option for track to set up a new track instance, only lets you do it the one time, right? So if I wanted to run the script again because something had broken, but the thing that had broken was before the thing that set up the track environment, then it might get set up, but then it's wrong. Anyway, it's chaos. So it's the last thing, though, right? So it's probably less of a big deal, but still, it might suck. So how do we fix it, Adam? What do we do? I don't know. So behind this thing is the word idempotence, and there's a big thing from Wikipedia, but I'm going to skip the thing from Wikipedia, which basically tells you that this term comes from math. So just trust me, it comes from math. Forget the math thing because it matters less. What it really means in the terms of our little script to install track is that each step in the process should ensure that the part of the system it configures is in the right state and do nothing if it's already there. So, Postgres already installed, don't do shit. That's it, right? Okay, say it back to me. Bingo! Okay, remember, because there's a test later. Okay, so in Bash, we could change my shell script to be idempotent. You can't read this because, I don't know, there's lights and stuff, but the gist is there's a bunch of if statements in here where I'm like running stuff and grepping for things and checking to see if it's true. I'm making it idempotent, right? The Juju guys are here somewhere. Where's the Juju guy? My favorite thing about Juju, when you kind of set stuff up, the little shell script has a comment in it that's like, make sure this is idempotent. Yeah, that's going to happen. So, and also none of them are idempotent, for the record. So talk to me after class. So here we are. It's the lightning talk. We drank beer. It's fine. So I like Gustavo. So this is the same thing. So we could make our bash script idempotent, for the record. That's an idempotent bash script. Does the same thing my little bash script did. All the things that are in it are idempotent. We added the little -e thing. It'll fail when it fails. Everything's cool. But it was a little bit of work, and I had to know how things happened. So in Chef, this is basically the same thing. Chef is a config management tool. If you took the little class earlier, you learned all about it. Don't have enough time for me to tell you how it all works. The shorthand is all this stuff could have happened in Chef. Each of these little resource blocks here that you can't really see, those are idempotent. It handles the idempotency for you under the hood, right? It knows how to take a resource, a description of the thing that ought to be, and how to make it so. And if it's not so, it knows how to do it. If it's already so, it... Exactly. Convergence. This comes out of idempotence. So if you've got all these little idempotent doodads, right, and stuff only does things if it has to do it, the next thing you get to do is convergence. And this is, again, the Wikipedia definition, kind of long. Short version is, if you have idempotent steps, you can just run it over and over until it works. So this sucks a little, but it's true. Let's say the apt repository is down on the upstream, and the first time you ran it, it broke. And the second time you ran it, it still broke. Third time you ran it, it worked again. Woohoo! Right? And the parts that could have worked will work, and the parts that can't work won't. It's not a panacea, but for the record, it's kind of cool. And it comes out of this fact that all these little resources are idempotent. So if they're all idempotent, you can just do it again, and things will converge. So let's pretend for 1 second. Oh, wait. What does that mean? So when I say convergence, it means nobody knows. Oh, no. No, that's idempotence. Convergence means if you don't do shit, I can run you over and over again, and it's cool. Gonna have to work on this one. Thanks, Artur. I should just have a talk that's like, buy SSDs. Okay. Then everybody would know what the message was. So let's say that we grow our track install. We're the coolest track site on the internet. People fucking love the stuff we publish on track. They're just like, whoa, track. I just Python and the little thing that shows the source code and the tickets. I freak out for it. So we got load balancers, we got databases and web servers, and we need one more theory. And this is like the most maligned theory in configuration management. But how many people here know who DJB is? Okay, DJB is right, and if you think he's wrong, you're wrong. You just don't understand why yet, right? That's the deal. Mark Burgess in configuration management, same deal. He's right, you just don't get it yet. And so he has this thing, and it's called promise theory. So idempotence and convergence, that's all kind of mostly Mark Burgess. Mark is right, and if you think he's wrong, you're wrong. Promise theory is his new thing. It's a little more complicated. You can tell, that's a lot of words. And it's an actual new form of deontic logic, if you want to get really, really complicated, but we don't need to. And so I'm just going to kind of zip you through what this means. Only the thing that makes a promise can keep a promise, and even then, they might lie to you, is what promise theory means. So I'll tell you why this matters in a second, because you're like, why does this matter, Adam? And I will tell you. So I'm going to use an analogy, and it involves Theo and Jason and hugging. So let's say I promise to not give Theo a hug. And if you know me, I like to hug people. If I've met you like twice, I'm going to give you a hug. And if you don't want me to, I'm going to forget. So the odds that I'm going to hug you, even if I'm like, I promise never to hug you, I'm going to do it. So Theo kind of hates hugs a little bit, right? Like, I'm sure he likes them from his family, but like me, not so much. So I love hugs. What's that? I know you did, but it's because you got used to it. I built you up to that. So Theo hated hugs, and now he loves them, but whatever. Fucking he's ruining my story. So I love hugs, and Theo knows that I love hugs. And so Theo tells Jason, make sure Adam doesn't hug me, right? Because he's afraid that I'm going to surprise him and just hug him. But I am fast, and I love hugs. And Jason, kind of slow, right? And Theo and Jason, they're not always in the same room. And so I'm totally going to hug him anyway. And the gist of that is, even though because I promised not to hug Theo, and Theo said Jason should protect me from hugging him, it turns out the only person who can protect me from hugging Theo is me. I can decide that I'm going to honor my promise to Theo and not hug him. And Theo can evaluate whether or not I have been consistent in my promise, right? Did I keep my promise to Theo? Theo knows that I shouldn't be hugging him. And if I hug him every time I see him, he's no longer going to trust my promise. And only through observing my behavior firsthand can you be sure that I'll keep my promises. And those observations happen by the person that I made the promise to. Theo observes that if I hug Theo, but I told him I wouldn't, then I'm a dirty, dirty liar. And when it comes to your systems, it turns out that this matters. In really large environments, not like 5 servers or 10 servers or even 20 or 100, but in really big ones, like pods of 16,000. Most of the time, they moved away from complicated orchestration. They don't have a lot of steps where they have a centralized observer, an orchestrator, looking at every single person in the room, being like, "Don't fucking hug anybody. If you hug somebody, I'm gonna turn you off. I'm gonna turn off everybody who hugs anybody." Right? Instead, every person in the room is like, "No hugs." And anybody who hugs anybody gets shunned, right? We're just like, no hugging here. We're a love-free zone. We want to live in an anti-Mandy land where everybody hates people. And the reason is that the problem with orchestration is the orchestrator. When you have an orchestrator who gives orders or who tries to enforce order on many, many places, things tend to get complicated very, very quickly. And they can work when you're small, but they don't work when you're big. So promise theory is about what? Hugs. Hugs is a good answer because you'll probably be able to relate my prime story. So promise theory is about hugging. Anything else? Lying. Hugs and lies. I think that pretty well summarizes what's happening. I think it also proves that, yea, though you can write a technical talk in a couple of minutes on an airplane, perhaps you ought not. And that is configuration management theory in 10 minutes or your money back.
Where's my hug? Oh my God. All right. Wow. Okay, I didn't sign up for that. Honestly, show of hands. We're winding down the regular lightning talks. Honestly, show of hands. Was this the best lineup of lightning talks you've ever seen? Seriously? All right. Now, the camera's only on me, so you'll have to trust that everybody had their hands up. Okay, we're going to take a couple minutes. We've got the karaoke lightning talk coming up real quick. If you volunteered for one, could you please come up in this general area?
All right, it's the study on scalability in social media.
Okay.
All right, it's psychological trauma on
I
cats
think it's about
with
Tech
automatic
Nine's not
weapons.
scaling.
All right, so this is actually one of the people that works in our operations environment.
And he was not listening to the previous talk, so you can see that's why it's good.
I think he was. This is a case where he's balancing stress with something a little more peaceful.
But he's got the safety on.
That
No,
or it's a skeet shoot.
This is the internet. It's tubes full of cats. Seriously.
It's awkward. Is that
So
a
that's
Facebook?
what they do with all that
Is
data.
that a Facebook?
Now we know.
Like Scorpion Man? What is that?
This is what
I've
Facebook
often-
does with your data.
Yeah. I always thought that Facebook stabbed me whenever I did anything, and now I know why.
Well, no, this is why Zuckerberg always wears a hoodie, right? He's got this tattoo on the back of his neck.
It's like a weird zodiac tattoo. It all ends in pain for Mark. The sun makes your Sunday melt, so you put it in a bag.
Well, there's several C words that you could use.
This is actually
That's gonna end in tears.
diagram. This is a diagram of configuration management theory. It didn't make it into Adam's slide stack.
Yeah, I cut that one.
Missing the hugs.
The bottom is where he steals your shit.
Correct. Where that equals money, so I can replenish the pension fund that I took money from to be here.
Was it good for you?
Next slide.
I'm Harry
Thank
Potter.
you.
That's a cool map.
But it's not a Mercator projection, so it's okay.
This is a representation. We heard about those distributed denial of service attacks, and this is where they're sourced from by country.
You might be actually right.
I'm actually pretty close there with the red one.
That's Mandy when she was getting her MBA.
Absolutely.
Sacramento?
Is that schnapps?
I mean, really? Sacramento?
Well,
College, dude. You're
That's a
little too
single
old
A
now.
conference? Is that right? Okay, so I heard a great quote that I have to repeat. I tweeted it earlier, but the use of time 15 minutes prior to an essay, if I could say it with a straight face, I retweeted someone overhearing this, which was, sure, I enjoy masturbation, but I don't put it up on GitHub afterwards. So, which kind of summed up all of GitHub for me.
Totally put it
So,
on GitHub.
12 hours prior to your
that.
essay.
So we are here
Foursquare,
at
right?
Postgres, right? It's an AT-AT. If it had a trunk, it'd be
Is
Postgres.
it made
I
of
think.
pancakes?
It is made of pancakes.
How many people here would totally eat a pancake AT-AT? Would you do it with peanut butter on it? I would. It's delicious. How about maple syrup?
Audience survey.
And Nutella.
Oh, Nutella. Look at you, fancy. Yeah. That's because you're from Pennsylvania.
How many would do Vegemite? All right,
Good,
next slide.
good. That's good.
Yeah.
This is my brother's dog.
Is that your brother behind the dog?
The day Admel got bought.
Looks like a Theo Hands code over.
I think this comes under Mandy's
right.
part about
This is-
being nice to everybody.
I'm an OmniTI customer too, so this is sort of their deployment process.
Yeah. That's why you need automation.
Next slide.
This is the sponsors for the concept.
Can we take Flickr off yet? Somebody still work at Flickr?
Okay, somebody from marketing actually made this slide. We won't actually admit that it's on our slide deck because it's obviously done by somebody from marketing.
This would be the missing links.
And on the theme of missing links,
Definitely stumble upon.
These are the worst slides ever.
Yeah, dude.
And
These
where
are the worst
is the
karaoke
call out
slides
for
of all
fortune?
time.
I mean, like, somebody actually invested time making these slides.
That's
And
awesome.
Jason spent time stealing these slides and then putting them up.
and what about the victims who had to sit and listen to somebody actually present this stuff?
Is it an Autobot?
It's the
Or
UK.
Decepticon?
It's
a
UK
GoBot.
Americans.
It's a
Half-Life
Go.
2.
Can't be a GoBot. There'd be no GoBots at Surge.
It's not Half-Life 2? Oh, wait. I'm dating myself.
This is a graph that nobody understood, including the author of the graph. And what's important as engineers, there are no error bars on this graph. So no
Anybody-
matter what it says, it doesn't tell you the truth.
Does anybody know what exotoxicity is? I'm pretty sure it's like your skin sucks.
I know what fresh water is.
The human toxicity on HTTP was interesting too.
That's not Mark Zuckerberg's tattoo.
Loves the internet. Love everyone on the internet. That's right. That's nice.
What state is that?
Shorts.
All right. This one deserves no introduction.
That redeems all slides so far. That's amazing. I just understand, like in the context, where is America's beard?
Don't want to know.
No.
All right, next slide.
Brian?
That'll be me later at the bar. Yeah, beer pong, and then we drink them all at once.
Nice.
Oh, this is from that methodology talk that I didn't go to.
Too many words.
I think this is, remember the graph from the quantum computer? That might be it.
It's a really bad slide. Is what
This
that
is the one that actually showed up from the parallel universes.
Yeah, that's what came in.
A little too quantum.
Wow.
Is that blurred out thing from before? Oh.
So this is a breakdown of body weight for Twitter users. So Twitter user usage for light users is a quarter, and heavy users is a quarter.
Who have no love.
And single visit apparently is a new weight category that Twitter users opted into. Thanks.
We're back to loving
We're not friends. That's not a hug.
He'll hug you later. It's fine.
Awkward.
I hate you. It is.
It's not a shower.
For whatever. It's not a shower.
Wow. Oh my god. It's not lemonparty.com either.
Are you regretting that we're
Or,
yet?
Man meet emu.
Yeah, that's right. You didn't buy an SSD. I think you have to come join us now.
Seriously.
Is that the data safety on S3
didn't come then.
diagram?
Yeah, that stops when you have kids.
I actually don't like this one. I don't always test, but when I do it in production. Is a much better one.
Age 1 year for every day you work with him.
Oh, yay.
This is the end.
We encourage everyone to drink to make it through tomorrow.